Okay. So in the last lecture, we have seen what is what are different types of sampling, what are different types of mixing, how you write the name of feedback amplifier. Then we have drawn all the diagrams of feedback topology, that is voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. And we have made the analysis of how the impact is there on input and output resistances with feedback. Okay, so and we made a table. We compared the RI and RO with feedback for all type of feedback amplifier. We have also seen what is the expression for that, and we have uh, understood what is sensitivity and what is desensitivity. Okay, so this much stuff we have completed in last lecture. Today, let's solve. First of all, let us solve a few problems, and then we will continue with the further part of this unit, which is based on oscillators. Okay. So first of all, we will solve a problem. Can you see the whiteboard? Is the whiteboard visible to you?
Yes, ma'am.
Okay. Make sure that it is occupying complete screen. Is the complete screen is visible with whiteboard?
Yes, ma'am.
Yes, ma'am.
So let's have a problem. Before that, let's revise the input and output impedances. So when it's a voltage series feedback, what happens to input impedance? When how what I told you how to remember this? The name, look at the name of amplifier. Look at the first letter and second letter. First letter is what you are sampling. Second letter is how you are mixing. So first letter belongs to, means you can visualize that when voltage is sampling, it is the part of output of amplifier. So voltage sampling means connections are in shunt. Therefore, output impedance is about to be decreased. So see here, ROF is decreasing. RO is getting divided by factor D. Okay. When mixing is series, input resistance is about to increase. So you see RIF is RI into D. Okay. Similarly, same applicable here. Wherever you find voltage, so whenever you find voltage, that way you are sampling voltage, you will find your ROF is decreased. Okay. Whenever you find current, current is sampled, you will find your ROF is increased. Okay. Now, this is about output because sampling is taking place at the output side. What about the input? Mixing is taking place at the input side. So let's see, when mixing is of series type, series mixing, series mixing. So what will happen to the input impedance at input side? It will get increased. See, your RIF is input resistance into factor D, RI into D. Now, if it is a shunt mixing, if this is shunt mixing, then input resistance is about to decrease. So see here, Ri is getting divided by factor of D. We have also seen what is the closed loop gain. That is what is the gain of an amplifier. Closed loop because we have applied the feedback. That is why closed loop gain. So for a voltage series. Which type of amplifier is this? Voltage series is a yes voltage amplifier, current amplifier,
Voltage amplifier.
this is a voltage amplifier. Current series is a
Transconductor.
transconductance amplifier. Voltage shunt is
Trans resistance.
current resistance. And current shunt is current amplifier.
Amplifier.
Right. A bandwidth, whenever you are applying negative feedback, bandwidth will increase. Now, when I say bandwidth is increased, so suppose the bandwidth of an amplifier with feedback, without feedback, I indicate it by BW without W by O. Okay. So, with feedback, it is about to decrease. So, bandwidth with feedback, I will denote it by BWF is equal to bandwidth without feedback into D multiplied by factor D. Similarly, we say noise get reduced. So, noise with feedback, if I indicate it by NF, then it will be noise without feedback divided by D. So, by applying feedback, noise is also reduced. Is it clear? Is it clear? Now let's move for the everybody take down the problem. Okay. First of all, we'll take very easy problem. Determine the gain with feedback for amplifier with open loop gain of 300 and feedback factor of 0.3. Okay. Take down the problem. Determine the gain with feedback for amplifier having open loop gain of 300 and feedback factor. Immediately you will calculate and tell me the answer. And feedback factor equal to 0.1. Oh, please tell me the answer. What is the question? Determine the gain with feedback. Means you have applied feedback, you have to find the gain. For amplifier with open loop gain of 300 and feedback factor of 0.1. So, you have applied feedback. We are studying negative feedback amplifier, so it is not mentioned negative feedback amplifier. So, its amplifier means a negative feedback amplifier. So, determine the gain. What is the formula for gain of amplifier with feedback? Yes. Yes, don't keep quiet. Unmute yourself. What is the formula for feedback gain?
XF upon XO.
That we have the X and all we have used for deriving. Then just now we have seen here AV. So we have to talk in terms of AV now. AVF. So AVF is the gain with feedback. GMF is the gain with feedback. Similarly, RMF, AIF. Now, what is the formula for this? We have derived the equation using negative feedback amplifier. So, gain with feedback AVF is equal to, if you remember, A upon 1 plus A beta. A upon 1 plus A beta. So, what is A? Is the open loop gain. Now, this will be voltage gain because we are finding voltage gain. So, AV upon 1 plus beta time AV. If you remember, this is plus sign here, which indicate that the denominator is higher, therefore gain is less. So gain of negative feedback amplifier AVF is equal, gain is equal to A upon 1 plus A beta, where A is the open loop gain. Because we are finding voltage gain, I am writing here suffix AV. So AVF, voltage gain with feedback, equal to AV upon 1 plus A beta. What is AV given? Open loop gain. Open loop gain means, what is a loop? When this is an amplifier A, you apply input and you get output. So whatever gain you get, A is equal to, let's say, output voltage upon input voltage. This is an open loop gain. Now, to the same amplifier, when I connect feedback, that is, I connect part of output back to the input. So it's a closed loop now. It is now becoming a closed loop. So in this case now, whatever gain I will find, I will call it as closed loop gain. Understood? Open loop gain, closed loop gain. So open loop gain means the gain of amplifier without feedback. What is it? It is given with open loop gain of 300. So this is 300 divided by what next? 1 plus A beta. What is the value of beta? Can anybody tell me? 1 plus, what is beta? Yes. Unmute yourself. What is beta?
0.1.
0.1. Beta is called as feedback factor or feedback gain. So beta is given here 0.1. You can write here given data. What is given data? You have given AV equal to 300 and second feedback factor beta is given as 0.1. Just a minute, students. I am also very glad to see you, students, after a long time. Just a minute, let me know. Yeah. So what is beta? Beta is 0.1. Okay. So right here 300 into 0.1. 0.1 into 300. Calculate it, tell me.
9.67.
Correct. So this is the simple problem. Because if you expect MCQ, such problem are likely to appear. So you get 9.67. 677. Okay. Next. Now the gain, I'm reading the problem. You just try to listen the problem carefully. The gain and distortion of an amplifier are 100 and 4% respectively. If negative feedback with beta equal to 0.3 is applied, find a new distortion in the system. Let me write. Note it down. Note this problem. You have to show me after the lecture. The gain and distortion of an amplifier are 100 and 4% respectively. If a negative feedback, what we are applying? Negative feedback. So if a negative feedback is applied, find a new distortion in the system. Find a new distortion in the system. Read the problem. The gain and distortion. Now what is distortion here? D. Okay, what we are calling as the sensitivity. So gain and distortion of an amplifier are 100 and 4% respectively. So A is given and beta is given. If negative feedback is applied, find a new distortion in the system. Okay, so this is second problem. What is given? What is given data? Write this given data and then solution. So what is the given data? A is given to you. Okay. And distortion is, sorry, distortion, the gain and the distortion. Distortion is 4%. Also, it is given that, you can note it further, beta is 0.3. Beta is 0.3 is also given. So AV is given, beta is given, and D is given 4%. What do you have to find? The new gain and distortion. So what is distortion? D is equal to, yesterday we have seen sensitivity and desensitivity. 1 upon 1 plus A beta is sensitivity and reciprocal of that is desensitivity. So it becomes 1 plus beta time 1 plus A beta, 1 plus beta time AV. Okay. So what will be new? After feedback, you apply feedback, so this will become 0.3. Beta is 0.3 multiplied by A is 100. That will become 31. Okay. Now you calculate percentage distortion. Express it in percentage. How much? 4% of 31. is equal to 0.129%. So such small problems may appear to find beta or to find gain. Okay. Now, suppose frequency is given to you, bandwidth is given to you, and beta is asked, that is feedback factor is asked to find. So you should be able to do that. Is this clear? Shall we take one more problem?
Yes, ma'am.
Everybody,
Yes,
you
ma'am.
understood this small problem? Because see, if the exam is MCQ, such problems are expected. Let's take one more problem. An amplifier has mid frequency gain of 100. You understand what is a mid frequency gain? How you divide the bandwidth of an amplifier in three regions. Do you remember? Mid frequency region, low frequency region. Yes or no? Yes or no? Do you remember the response of an frequency response of an amplifier? Please unmute and tell. Do you remember frequency response? Everybody unmute yourself. Frequency response of an amplifier.
Yes, ma'am.
How many regions you show there?
3, ma'am.
Yes, what are that?
High frequency, low frequency, and mid is bandwidth.
Correct. Middle frequency. So middle frequency region use how are the how is the gain? Is it varying, increasing, decreasing, or constant?
Constant.
Correct. In the mid frequency range, the gain is constant. Okay. So now understand the problem. Third problem. An amplifier has a mid frequency gain of 100 and bandwidth of 200 hertz. Okay. First, you have to find now what will be new bandwidth and gain if negative. What will be the new bandwidth and gain if 5% negative feedback is introduced? If 5% negative feedback is introduced. Second, now you have to tell me the formula. Okay, you think on this. What should be the amount of feedback if the bandwidth is restricted to 1 megahertz? Understand the problem? In an amplifier, mid frequency gain is 100 and bandwidth of 200 hertz. So is this with feedback or without feedback? This is the what first statement indicate with feedback or without feedback? Yes.
With feedback.
Amplifier has a mid frequency gain of 100 and bandwidth of 200 is with feedback or without feedback? Further, it is asked that what will be the new bandwidth if you are applying negative feedback. So whatever is given in the first statement is without feedback. So without feedback, the gain is voltage gain is 100 and bandwidth is 200 hertz. Okay. Now what you have to find, what will be the new bandwidth and gain? So you have to find new gain AVF with feedback, because we are saying after applying feedback of negative feedback of 5%. So we have to find AVF with feedback. Okay. 5% negative feedback means you are supplying 5% of the output back to the input, means your feedback factor. What will be your feedback factor in this case? Beta will be, it is 5%, so it will be 0.05. Understood? 5% feedback means what is feedback factor? 0.05. Convert it into feedback factor. 5% feedback means 5% of output you are connecting back to the input. It means feedback factor is 0.05. So what will be your new gain equation for new gain? It will be AV upon 1 plus A beta, AV into beta or beta into AV. So what is AV? 100 divided by 1 plus beta is 0.05 into gain is 100. What is the answer? AVF is equal to
16.66.
16.67. Very good. Second, what is asked? What is the bandwidth? What is the new gain and bandwidth? So first part, I'm doing the first part. This is first part. Sub part. Bandwidth. You know, after feedback, bandwidth increases. So I will call the bandwidth after feedback BWF is equal to bandwidth without feedback, that is BW, into, you know, whenever it is increasing, it gets multiplied by factor D. Okay. What is D? 1 plus A beta. 1 plus A beta. So what the new bandwidth is? What is the old bandwidth? 200 means not old bandwidth, the bandwidth without feedback. That is 200 hertz. Okay, please change this as 200 kilohertz. This is very less bandwidth. 200 kilohertz. 200 kilohertz. So 200 into 10 raised to 3 hertz. And this factor you can find 0.05 into 100. How much it comes? Yes. What's the answer?
12 into 10 raised to 5.
12 into 10 raised to 5 means 1.2 into 10 raised to 6, right? Means 1.2 megahertz. 10 raised to 6 means megahertz. Correct. What is the second part in this? Read the second part of this problem. What should be the amount of feedback if bandwidth is restricted to 1 megahertz? Now, it is simply twisted. Second part. What should be the new bandwidth New bandwidth means, of course, bandwidth after feedback. So bandwidth after feedback, BWF, what should it be? किती
Excuse me,
असायला
ma'am.
पाहिजे? Yes,
Ma'am, my answer is wrong. It's 1.0 megahertz.
you please recheck it. Here it is 200, no? So you will get 1.2 megahertz. I did it. You please check. Okay. Bandwidth, BWF, that is bandwidth after applying feedback, is equal to bandwidth before feedback, means without feedback, multiplied by 1 plus A beta, right? Now what is said that bandwidth is restricted to 1 megahertz. Your what should be amount of feedback, means you have to find factor beta. What you have to find? Beta. Beta is what? If bandwidth is equal to 1 megahertz. Bandwidth is equal to 1 megahertz. Okay. So let's keep the new bandwidth as 1 megahertz, that is 1 into 10 raised to 6. This is equal to what is the old bandwidth? 200 megahertz. 200, sorry, kilohertz. 200 into 10 raised to 3 into 1 plus beta you have to find. So beta into our AV was 100. So just find beta. So you will get beta. If you solve this for beta, you will get beta equal to 0.04.
0.0.
Correct. Okay. So you have find it new beta. You have find it here AVF. And you have find it bandwidth feedback. So this kind of question can appear in MCQ. So let's move on. Now we will start the next topic as oscillators. Have you heard the name oscillator? Have you heard the name oscillator? Before that, I will give you the example. Now we have seen current series, we have drawn the block diagrams of all type of feedback topology, of all type of negative feedback amplifier. Okay, so let's see how, if I want to build a circuit, how will it look? First of all, tell me, can you see the screen? Can you see PPT?
Yes, ma'am.
Yes, ma'am.
Tell me, current series feedback is which type of amplifier? Current amplifier, voltage amplifier, transconductance, or transresistance?
Transconductor.
Transconductance.
Transconductance. Good. Current, that is you are sampling current, and mixed in series. So in series we used to use mix voltages. If I want to mix current, I will use it in, I will use shunt mixing. Okay. So you know current series is a output is current and input is voltage. Okay, so it means it's the ratio of I to V, that it is, it's a transconductance amplifier. Okay, transconductance amplifier. So we define the gain of transconductance amplifier like this: GM is equal to, so look at this amplifier. So this is your MOSFET, 2N7000 IC is used. This is your MOSFET. Drain resistance, this is voltage divider network formed using R1 and R2. This is the voltage divider network. This is your source resistance, and whenever you are using source resistance in an amplifier, use a capacitor in shunt with that, so that your AC output voltage will appear here and it will not drop across RS. And this is the drain resistance RD. Here you are taking out, and here you are applying input through a capacitor. You are taking output through a capacitor. Okay, so this is the basic structure of amplifier we have already studied. Input voltage is Vi and output voltage is Vo. This is your input voltage. This is your output voltage. Right? For output, we will say output current is IO. Input current is II. So what input voltage, let's say signal voltage you have applied is Vs. So for this, if you want to write the expression for transconductance, so it will be output current upon input signal voltage. So output current is IO upon input signal voltage is Vs. IO by Vs without feedback. And this is also IO by Vs with feedback, because I am showing the only this signal, feedback signal. I will now explain you. Similarly, if you want to find Ri, it will be input voltage upon this input current, and Rif will be input voltage upon input current. What is the difference between that? I will tell you. Now you know after applying feedback how output resistance increases, how input resistance increases. Okay, because in this topology, your input and output resistance is about to increase. Okay. Now, how you can say it is a current feedback amplifier? So this is your output available. This is the output available. Okay, you are taking output between these 2 points. So your AC output is available like this, not like this. Suppose you are giving this signal input. So your output is like this. Okay, this is your VO. You have connected here a capacitor. Okay, currently, see, if you can see a switch is connected here. I'll explain you how feedback is happening in this circuit. So when I am connecting here a switch, this AC voltage, which is, am I audible clearly?
Yes, ma'am.
So when you, please zoom your screen and see. Now don't look at this formula, look at the figure, circuit diagram. So you have output signal available at the drain terminal. But this switch is closed. When I say this switch is closed, it means this capacitor is there in my circuit. So whatever AC, see, because here there is AC, the same AC signal, AC current will flow through this RS also, means at this particular point, total current flowing here is the DC value of IS plus AC value of IS, right? Out of that, I have connected here a capacitor. Therefore, whatever AC is there, that will be bypassed through this capacitor. AC will not flow through this RS. Okay. AC will not flow through this RS. And therefore, there will be no AC voltage developed across RS. Now look at this resistance RS. This is the part of output side as well as input side. This resistance is the part of output side, okay, as well as it's a part of input side. Okay. So when I am connecting a resistor, when I am connecting here a capacitor through this switch, it means the output is available only at the drain, and across RS it is not available because it is getting passed through this capacitor. Okay. So because there is no part of output voltage is developed, I will say now at input side there is no feedback is applied. Now when I want to, this is without feedback. So remember, when I am connecting here this capacitor through this switch, it means this is without feedback. Now if I want to give feedback, what shall I do? If I want to give feedback, then I don't want this capacitor here. So remove this capacitor or open the switch. Open the switch. Let the switch be like this. Open it. Okay. So it is disconnected now. Now what will happen? The current which was flowing, which was IS plus IS, that is IS DC plus IS AC. So now what will happen to this AC current? AC current will flow through RS because now there is no capacitor. So AC current will flow and it will drop some voltage across this. It will drop some AC voltage. Now look at this input side. What is your total input voltage which is receiving by this? It is the sum of the applied signal Vs. Okay, Vs signal you have applied, and this voltage which is present here becomes your feedback voltage. Part of output is present across RS and same is present in the input circuit. So the voltage which is appearing at the gate terminal is the sum of Vs plus sorry, let's call as this is, I will call it a signal voltage as well as the source voltage. Are you getting? Apply केलेला input हा Vs आणि RS च्या अक्रॉस जो आउटपुट सिग्नल ड्रॉप झालेला आहे हे दोन्ही इथे मिक्स होणार, right? And that is given to the input of the amplifier. So this is what mixing. काय ऍड होतंय बघा, voltages ऍड होत आहे. This Vs and the voltage across RS are getting added. It means this is series mixing is happening here. Series mixing असताना voltage mix केले जातात, right? Voltages add केले जातात. So this voltage and this voltage are added. Now you know what is addition. Like if there is a phase difference, so it will be this minus this, and it is a negative feedback. And this way you are getting the feedback. Clear? Have you understood this? When this is a current series feedback amplifier, when I can call this as a feedback amplifier, when this switch is open, means disconnect this, it will become a feedback amplifier. Connect this, it will become a amplifier without feedback. Clear? Is it clear? जेव्हा कॅपॅसिटर कनेक्ट केला तेव्हा फीडबॅक राहणार नाही. The AC signal will be passed through this capacitor and there will be no part of output voltage dropped here. So it cannot be mixed. Okay. So this is amplifier without feedback. And if you want, sorry, yeah, this is amplifier without feedback. If you want feedback to be connected, open the switch, so that capacitor is disconnected. आता capacitor नाही आहे. So part of our output voltage will be dropped across RS and it will be mixed here with the input voltage. So input voltage here will become the signal voltage and the voltage across the source resistance, and this way it will become feedback. So you have to perform this experiment in multi-sim current series feedback amplifier, and you have to note down what is value of IO. So you have to find IO as VO by RD in both cases, when feedback is there and when no feedback is there. Similarly, you have to find this ratio when feedback is there. So first experiment you have to perform by connecting this capacitor, that is without feedback. Then second experiment you have to find by disconnecting the capacitor, then it will be without feedback. Understood? Have you got this? Yes or no?
Yes, ma'am.
Yes, ma'am.
This was current series feedback. What was the out in this current series feedback? We say we sample current. Okay, so who was how you can say what current we have sampled? See, this was the output current. The current was flowing through RS, therefore the voltage is dropped. So we have taken the output current that has developed some voltage, and that voltage is mixed. So it is current series feedback. Voltage. Now I have to take the part of output as a voltage. So now see, where is my output? Output I have connected at the source. Okay, this is a output is present at the source. In this case, this is source follow. Okay, output when the output is present, whatever output voltage is developed, या सर्किट मध्ये आउटपुट कुठे आहे बघा तुमचं, इथे आहे. तर या सर्किट मध्ये जे व्होल्टेज इथे तयार राहणार आहे ते इकडे फिक्स होणार आहे. सो इट विल गेट मिक्स विथ the signal voltage Vs and this voltage. If you find the voltage between these two terminals, it is the sum of this plus this. Okay, so if you want to find sample voltage, see where this is connected. If you want to find if you want to have current sampling, so output will be connected over here. This is the small signal model I have drawn. I taught you how to draw the small signal model. I have to replace this by its small signal model, and you have to make all the DC voltages to the ground, short all the capacitor. So how it appears, that is drawn here. So in there, I have taught you already. You can see RS is present here. This is your this much part is the small signal model of a MOSFET. You know, here we represent open circuit. Okay, VGS open circuit. And this is GM into VGS. This is a current source. Okay, this is the parallel resistance of this current source as the output resistance of MOSFET. Then if you ground drain voltage, VDD, if you ground VDD, RD will appear here. Okay, and RD will input resistance R1 and R2 will appear here. Along with that, there is RS. Okay, now this RS is broken into two parts, and why we have to do that? So that I will explain you after the further section. Okay, when we'll again come back on the AC model. So we have applied some, because this, see, RS is appearing in the out. RS is appearing in both sides. When you apply feedback, this RS become part of input as well as part of output. So it will appear at both sides where it is connected between the source and the gate. So this is our source and this is the gate. So between source and gate, this RS appear. Similarly, it will also be reflected in the output because you are giving feedback. Okay. Now let's move on an important topic. Yeah, we have 5 minutes only. Have you marked your attendance? I'll tell you about Barkhausen's title. Okay? Okay. So now we will see what is an oscillator. Okay. So do you know what is oscillator? Can anybody tell me what is oscillator? Do you have any idea? Please tell me. Yes or no? Do you have any idea about oscillator? Speak something, yes or no? Have you heard this name before?
Yes.
Okay. What is that oscillator? What oscillator do?
Produces electric signal.
Okay. Oscillator is a circuit which produce the oscillations, right? Oscillations. So you may have different types of oscillation. Like when I say it's a sinusoidal oscillation, it will be producing sinusoidal waveform at its output without giving any such kind of input. We have seen amplifier. In the amplifier, we used to give an input signal first of all. And then you get the amplified signal, which is enlarged version of this. But if it's an oscillator, it will give you the continuous waveform. Okay. So it may give you sinusoidal waveform, square wave, triangular wave, depending on the type of oscillator. So sinusoidal oscillators are the circuits which are providing you the oscillations with constant amplitude. Okay, constant amplitude, and you don't have to give any input signal for this, like an amplifier. Whatever power supply you are providing DC voltage for its operation, that becomes the input. So what is an oscillator? Oscillator is a circuit which is providing you oscillations of constant amplitude, right? See, I can have different types of oscillation. First of all, here I am showing the amplitude. This amplitude is continuously decreasing with time. Okay. Here I will show another waveform. What is happening here? Amplitude of this signal is increasing continuously with respect to time. And third signal I will show that amplitude of the signal remains constant. What is happening here? Continuous decrease in the amplitude. Here continuous increase in the amplitude, and these are constant amplitude. So this is called a sustained waveform. Okay. These are the damped oscillations whose amplitude is changing with respect to time. They are damped, and this is undamped, and we want undamped oscillation out of a circuit. Fine. So we will stop here today, and we will complete what is Barkhausen's criteria and what are two different types of oscillator in the next lecture. we have to study phase shift and wein bridge oscillator. So you try to learn today if you have time. You just go through what is Barkhausen's criteria. Okay, what is Barkhausen's criteria? Let me check your attendance.